make things easier. Read the question. In the collisions, I'm bringing some friction concept. So this directly will take this is the I solved by that method. Anybody having easy method, you can proceed with that easy method also. It's not that teacher only is correct. If you have some better idea, you can solve the previous problem with still more easier method. Now look at the question. No? There's a viscous force. This will be rough. This will be rough. There's no friction between the block and the floor of the box, and there'll be a friction between the box and the ground. So small corner, we have a ear block here. It may not be visible properly. Red color I'm putting it. There's a ball, that one. Small block of rest to the left of box of equal mass. So what is the mass of the block as well as the box? Both are same, and it's saying elastic collision. If the block is given velocity 10 meter per second towards right, I'll proceed with the directly with the diagrams here. No, first what will happen? There's a floor. The box will be there only, no? It will not move. Only the block will move, and the block what happen will arrive here. It will arrive with a velocity u, and the block is still at rest. Now collision occurs. After collision, exchange of velocity occurs. Exchange of velocity occurs. Let me. So now what will happen to the box? No, box will acquire the velocity u, and the block what happen will be at rest. Can be asked in advance. I'm making things clear because we do got habituated of particle to part two balls collide. Everyone will solve because that conservation of momentum, quotient of distribution apply, you'll get the answer. These are some problems where related to some situation. And next, what will happen? The box will not be there on, so it will reach here. So now what is the just before collision open, what is the state of the box? Box will have velocity u and the block will be at rest. Now collision occurs. Now tell me, after collision, will it have same velocity u? No, it should have some velocity, so call v1, velocity of the box. Let it be v1. It will not come with velocity. Now it will collide. Then after collision, again exchange of velocity occurs. So then here the block will come to rest. So the box will come to rest and the block will acquire that velocity. How to calculate V1 we'll see, because the frictional force, the viscous force is varying with speed. No, let's see that one. So this will have velocity V1 and the box will come to rest. Now the box will be there only. See this sequences, 1 or 2 diagrams when you draw, I think you'll come to know, okay, what to do. You need to get scared. and this will be at rest, and the block just about to collide, and it will have velocity, say v1. Now what will happen? Exchange of velocity occurs. So the block will give that velocity. This will be v1, and the block will be there only. I think I explained enough of this one. After this, we have to generalize it. We can't keep on diagrams. Huh? Drawing diagrams is not our problem. It's a part of a problem. Like that, sir, I'll keep on draw diagrams. We don't know how many events will occur. Maybe 200, 300. So you can't draw so many. So at least I think by this time you should generalize here. Okay, this is a sequence that occurs. So what is the state of? This will be at rest. Now, very next moment, one more last. I think this is it. The velocity will be given to the block. And the sequence will continue. I don't have patience to further draw diagram. I think this is enough for us to generate an idea what's going on. Okay, let's come to the question now. So what is the question like? Asked. How many times will the block collide with the walls of the box, and how far will the box move? Whose help you are going to take it? How far the box will move? I'm very good in little bit of the friction idea. No, here viscous drag is there. How the viscous drag will be acting on the block or on the box? Suppose this is a box, and finally it will move some distance, say x here. So here I'll start from here. It is having a velocity u. Let's not bother about that one. And finally it has come to rest. So when it is moving in between, problem you can make simple when you generalize it. So when it is moving in between, tell me what actually happens. A viscous drag will act here. And look at that viscous drag. Will be opposite to velocity. So no, is it continuously will act? No. Only when box is moving, the viscous drag will be acting here. No? So therefore directly I'll write the equation F is equal to minus kV. And what is F? The viscous drag is equal to minus m dv by ds is equal to minus kV, or dv by, so v dv by ds. It is v dv by ds. So one v will get cancelled. So on the LHS we'll have only dv. So this will be minus k by m ds. Can we calculate total distance moved by the box? This should be equal to initial velocity u, final velocity 0, it comes to rest, 0 to L, or let it be S. So this should be 0 minus u minus km S, or S equal to mu by k. This is the total distance moved by the block. After this, how to calculate number of collisions? Whose help I should take? Let's do one thing. Can we calculate V1? Can we calculate V1? L is the length of the box given. So how much of distance the box, in fact, it moves. I think the diagram is helping us a lot. No? So how to calculate V1? The same, the limits dv equal to u v1 equal to minus km. This is ds 0 to L. No? So v1 minus u equal to minus kl by m. So k we know, L we know, m we know, and u. So this is v1 equal to u minus kl by m. What about v2? v2 equal to v1 minus kl by m. So in terms of that, when you substitute here, how much you'll get? U minus 2kl by m. Shall we generalize like this? And what is v3? v3 should be equal to u minus 3kl by m. So vn equal to, finally it'll come to rest, no? So what is vn? Finally it should come to rest. So what is n equal to? mu by kl.